So we're going to talk about urban geomorphic lessons learned. And this comes from a talk that's just a little bit too long for this, so I'm just summarizing the lessons learned at the end of the presentation. And some of these things you guys have heard before, other things you probably haven't heard. So feel free to chime in if you hear some of this stuff again and say, hey, but I really thought that this might actually work better, and I've heard that before, but I was thinking about this. So I'll try to talk with some pauses. So the first one is floodplain interactions. Back in 2006, 2007, I went to Kentucky and I worked with a friend. I was looking at forensic failures of stream restoration projects, and we thought that it was all going to be related to the bankful flows. And we realized after we started looking at it that, well, these people designed a channel that had pretty good bankful dimensions, and we couldn't have done any better to design this channel, but yet it was still failing miserably. And it was a place where they were going to sue the engineer, and the engineer was a friend, but yet, I didn't know that until after the fact, and we were trying to figure out why it was failing. We started looking at these floodplain interactions and realized that floodplain interactions had a huge impact. Before that time, a lot of people were saying, well, just design a bankful channel. And what we realized at this point is that the bankful channel is good to design to, but we have to be thinking of things beyond the bankful channel. So multiple flows, and each multiple flow should have a different pattern associated with it, because the flood flows will also be different as well. So what that means is that we moved into this idea of having multiple flood flows, and each one of these horizontal lines, the pink line or the magenta line, the yellow dash line, the green solid line, and the blue thick line, they all represent a different design flow in the channel. And they all have different dimension pattern profile associated with them. And this started being one of the first times that we were designing for multiple flows. Now, we still have a hard time designing for every flow that comes through, but you're going to get a better range of flows when you're designing for 4 or 5 discharges than when you're just designing for one bankful discharge. The next thing we looked at as floodplain interactions is this convergence and divergence flows. This failed project had a lot of places where they pinched the flow in due to roadway culverts, and then they spread it out due to places where they had good easements, and then they didn't have an easement, so then they pinched it back together again. And we realized that where we had 5-to-1 transitions to 4-to-1 transitions, we had problems with sediment transport, and we had real big errors. And then also where we had things that seemed to be about 20 to 30-to-1 change in vertical slopes, we started to see transitions. So places where it got a lot steeper, a lot flatter, we started to see in transitions. So we came up with design criteria for urban channels saying that we wanted 10-to-1 transitions horizontally, just because it was about 2 times greater than what we saw failed projects at in the past. We didn't have any hydraulic modeling, we just saw failed projects, and we said, hey, we don't want to have a failed project, so let's make the transition a lot more than that 5-to-1 transition, and we did 100-to-1 on vertical slopes. And then and that just meant that we have gradual transitions where we have to have a transition in the floodplain. So if we go from one place where we're constrained to a place where we're not, we will make sure that we just narrow up the floodplain. We'd rather take a little bit higher shear stress and mitigate for that shear stress than have a convergence or divergence issue if we have a higher sediment transport load. If we have clear water discharge, it may not matter. And then the final idea of floodplain interactions was turning of the design flows. And at this point, we had reference reaches for a lot of bankful channels, but we didn't have reference reaches for floodplain channels. So a lot of times we saw people that would remember working with George Kelly years ago, and we saw a failed stream restoration project, and we thought that the bankful channel was too small, but it ended up being that the radius of curvatures were just too tight for the floodplain. They made the radius of curvature change be as tight on the bankful channel as it was on the floodplain channel. So one of the things we look at that's turn design flows is, let's say we have 5 design flows that were designed to an inner berm, a bankful, a flood terrace, a 100-year discharge, and a regional discharge. make sure that the width of any one of those flowing discharges does not turn at a radius of curvature that's more abrupt than 2 times the width of the flowing water. And that's a reference that we got from the Army Corps of Engineers years ago, but it has seemed to work pretty well. The next point that we looked at is energy dissipation in urban systems. We've seen a lot of urban systems where they put in just a straight line channel and they don't put in any kind of concave pools or they don't put any kind of pools, and they have longitudinal profiles that have a concavity that decreases as you go downstream. So in other words, it's like a hinge point in the valley. So what we noticed in doing urban stream design, this is a project that Brad and I worked on years ago in Cary, North Carolina, is that when you're looking at urban stream channels, we definitely want to see that at higher flows, we don't really see a break in the water surface slope, that it all becomes the same slope. We want to see that flow reversal so we can reduce our bankful slopes so that our low flow slopes are steeper than our bankful slopes. What that means is that we have less of an increase of shear stress as the water increases. So we still increase the shear stress, but it doesn't increase as much because the slope is reducing. We saw this in some early failed stream restoration projects from the early 2000s up in Ontario, and we noticed that they put in a straight line channel, but yet we came in a couple years later and the channel had scoured out, but it also created this pool-to-pool spacing feature in an urbanized system that was very predictable. So we saw that pools were formed even though the pools were not constructed. So the idea of looking at existing pool-to-pool spacing on urban channels is important because a lot of times that will tell you where we need to place pools in a disturbed reach when we're looking for restoration. The third idea is looking at central tendencies of rivers. So on the urban channels, it's important to look at scour lines, deposition, bankful features, and the pool-to-pool spacing and compare that to reference parameters. So this is in Houston, Texas area. This is a 100-year flood channel that you can see the slump slopes from the side slopes, but this channel was built as one big trapezoidal channel. And the central tendency of this channel is that it's forming a pilot channel inside the old channel. That pilot channel has a sinuosity associated with it. It's supporting vegetation. So looking at the central tendency of where deposition and scours occur is really important. We saw this on a project we did looking at scour potential up in New York years ago on a landfill as well. But looking at that scour potential helps us understand where we can place these channels away from urban constraints and say, okay, well, if this is our scour potential, then let's move the geomorphic floodplain away from here, and then we can still use this area as floodplain and reduce risk. The fourth idea is looking at, on urban channels, it's really important to look at reference shears. And what this means is looking at the materials that are going to be available to it, the vegetation that you expect to come down through the site, and looking at where we have rack lines and having a better understanding of how much resistance to a force that vegetation can withstand. So if we can remember Brad and I did a project in Medicine Hat, Alberta years ago, and the whole idea of this project was we were trying to understand how big of a floodplain we had to create. All the documentation told us we need a really big floodplain, but yet our side slopes were very fragile soils and very steep in this old coulee. And a coulee is essentially a drainage ditch that doesn't pick up a whole lot of water and is only really picking up the water that falls on the shape of the drainage ditch. So it becomes a very fragile sediments because it hasn't been formed over years and years of flowing water from upstream. It's really just what falls on the shape of the ditch. So we wanted to look at what vegetation would withstand, and for us, if vegetation could withstand a higher force, that means we didn't have to cut as far into the hill slopes that we were concerned about long-term stability if we did so. So we went down and we looked at the vegetation that was down there. We measured the width of the floodplain as well as the depth of flowing water over the floodplain where we didn't see deformation. We used rack lines to look at that depth of flow over that floodplain. So we walked down in the floodplain and said, okay, this is where we're seeing deformation. This is where we're not seeing deformation in the floodplain. So where we're not seeing deformation, we can use this native vegetation to withstand this shear force that's being applied. That's really important in urbanized systems as well, because we usually don't have enough floodplain. And if we don't have enough floodplain, then we have to start looking at mitigation methods for that floodplain. And that's important because the reference values we use, a lot of the reference values for reference shear stress come from the Ag Research Station or the Army Corps of Engineers, and a lot of that's based off of data that's been collected in the vicinity of Vicksburg, Mississippi. Obviously, Vicksburg, Mississippi has a lot more rainfall than Denver, Colorado does, and has a lot less rainfall than Portland, Oregon does. So there's vegetation, the strength of the vegetative roots, if you've ever planted a garden, is going to be related pretty closely to the amount of moisture that's available to the plant. The density of the roots is going to be related to how much water you have. If you don't water a plant, you're not going to have very dense roots. And then the final thing is look at mini regional curves in urban environments. I remember having a discussion with Douglas Shields Jr., and he's a person that doesn't believe that natural channel design has a place, should be used as a tool for urban channels. And I got done presenting this at the 2010 Federal Agency Sediment Conference, and he came up to me after the thing and said, there's really no reason that urban channels should be used, that natural channel design should be used in urban environments. And what came out of the discussion is that, you know, a mini regional curve itself can help you understand where vegetation will establish in a channel, even if you don't have high sediment loads. And his argument was, you don't have high sediment loads, so why does it matter about using this process of natural channel design because there's no sediment load? Well, I do believe that urban channels do have sediment loads. A lot of times they're reduced, but even just knowing where we can have vegetation established and the depth of water table is important. That's something that can come out of these mini regional curves. So looking at a mini regional curve is looking at multiple depositional surfaces and where vegetation and scour are related to those surfaces. So we think about this related to the Harris County curve, and we looked at multiple depositional surfaces and looked at, okay, well, how can we design 4 different stages of a channel based on reference criteria we have, and can we correlate that back to drainage area? So what we looked at here is not just a bankful regional curve, but an inner berm regional curve and a top of bank regional curve related to percent imperviousness for different areas related to urbanization. And that helped us guide what we called a 3-stage channel design, and with the 100-year discharge on top of that, or the regional discharge on top of that, that would give us a 4-stage channel design. The mini regional curves are important. They also help us, as I talked about earlier, sometimes we think that people identify bankful wrong, and that's why a project failed. This is a project we did with George Kelly years ago, and we went out and looked at a channel, and it was supposed to be the bankful channel. I thought was going to be all wrong. We went out to the mini regional curve, found out the bankful channel was actually appropriate, but what they had problems with was, as I mentioned earlier, floodplain interactions. But the mini regional curve can be used to help us identify, okay, well, maybe it's not so much that we have the wrong size channel, we just don't have enough flows that we're designed to, or we don't have enough channels that we're designed to. And our final thoughts are urban channels and using natural channel design in urban settings. Really, it should be a process-based design, meaning that we need to lay out our goals and objectives and tie our goals and objectives to why we're using a tool. Using natural channel design is very useful, but it should not be used as a religion or a stepwise methodology in an urban setting. We have to use it as kind of a backbone or a basis for our design, but we don't want to use it as our religion and say, hey, let's do this step, this step, this step, this step, because I can guarantee you that looking at alluvial channel design that's laid out in natural channel design processes is not appropriate for most urban channels, because you don't have a high enough supply of sediment coming onto the site, because sediment has been held back from urbanization issues and pavement in the upstream. Identification of bankful is always important, even in low sediment supply systems, if for nothing else to help you understand where you can expect revegetation of different ecosystems. And flood stage reduction in urban systems should always be considered as a selling point. And invest in the pretty. In other words, in urban systems, it's really important for aesthetics. Don't underplay aesthetics and say, I just need a functioning ecosystem. One of my favorite studies to look at is a study by Peter Wilcox that he put together years ago when he was at Johns Hopkins University, and he was trying to show that natural channel design didn't really have a place in urban systems. So he went out and he just surveyed people, landowners, and said, what do you think about this stream project? And he expected people to say, well, it's a big waste of money. It's not doing very well. And what he looked at, the effects on the Chesapeake Bay. And at that time, and since then, some of these ideas have changed. But at that time, he said, well, the stream restoration is not having a big effect on the Chesapeake Bay. But through his survey, what he found out is that landowners like stream restoration projects. It pulled them into natural areas, and that there was a value, if nothing else, even in the aesthetics in these urban systems, and that people want to see something that's naturalized. And it's a really neat study that he had said, and it was neat how he's presented over the years, that he really wanted to find a reason to kind of debunk using natural channel design. And he found out that aesthetics and these park-like settings and connecting people to nature was a good enough reason, even if you said there wasn't a reduction in even if you said that it didn't have much of an effect on the quality of the bay at the time. Now, since then, I know George Kelly and others probably know of a lot of researchers that say things that are slightly different than that. And this was just Peter Wilcox study at the time. So, threshold channels in urban systems are important. We generally have to hold riffles in place because we're not going to have resupply sediments. So finding ways to make channels look nice while still not letting the riffles move is important in urban channels. And, natural channel design is better than the alternatives. This is a project that was successful in Houston, but its lifespan's done. Concrete's cracking. You didn't have proper drainage behind this concrete. And, can we come out with something that we can naturalize these channels and make it better than this alternative in years? Will it get stronger as it ages opposed to weaker as it ages? So natural channel design is useful in urban systems. Bankful is important, even though it's uncertain. And natural channel design really shouldn't be used without other design tools. If nothing else, we need to be looking at risk analysis. We need to be looking at HEC-RAS. We need to be looking at the idea of where we can put in threshold riffles, not just the standard natural channel design methodology. Urban projects should, at a minimum, address uncertainties and risk analysis, and this generally hasn't been associated with natural channel design processes in the past. And this presentation was in 2010. It was presented in front of Dave Rosgen at the Sediment Interagency Conference, as well as others. And unfortunately, I would say that risk analysis and uncertainty analysis is still not included in natural channel design as taught by Dave Rosgen and others. Now, he doesn't say you shouldn't do it, it's just not taught that way. I think that's something we can add to the industry, really encourage that natural channel design is done in a way that we can look at risk assessment in urban systems. So with that, that's my presentation on urban natural channel design, urban stream restoration today. Any thoughts, questions, concerns, comments?
That was a really fast overview, Dave, but it was really good.
Yeah, at least it wasn't 70 slides. I cut it down to 20.
Yeah. It's neat because it's got a lot of the rules of thumb in there that you only get after doing this for years and years and years.
Yeah, and those are all the rules of thumbs that's in this presentation. I had updated. Some of them were slightly different on my original presentation, but they're all kind of the same ones that we're doing, that we're encouraging people to do now. So.
And watching you is kind of like Alex Trebek, you throw in the odd Canadian thing just to try and help teach the Americans, so I appreciate it.
Hey, you bet, eh? Keep your stick on the ice.
It's also Victoria Day. It's a holiday in Canada today.
Oh,
Brad, that was one. That was one funky looking Kool-Aid there up there. So Dave, yeah, a couple thoughts that I had, and I'm not the technical guy here, but I do see this a lot when we're trying to do work in urban areas, which is two things. One, is so important relative to your goals and objectives may be so different from your traditional goals and objectives in some of the hinterland areas. And a lot of times it may be stormwater related, it may be flood reduction related, it may be recharge related. And those warrant different approaches. And I think that to me is one of the key things, is that sometimes your orientation may be very different, that's driving those goals and objectives. And then the other thing is this multiple benefit approach. Flood reduction can be a huge issue in a lot of the urban areas we work in, and the more we look at integrating, that element into the equation, the more sellable these projects are, the more financeable these projects are. So those are my only thoughts. Welcome your guys' thoughts on that.
Yeah, I think we're finding ways to sell projects in urban environments differently than what we had historically, and that they can find different values. And it's just important that we don't sell a process that could potentially be used in error just because we're too proud to step away from that process. And that's essentially what I was trying to say with this natural channel design presentation. It's a great tool, but it cannot be a standalone tool in an urban environment.
Hey Dave, I had an idea on this a while back. If you have really good hydrology, you could actually back out an equivalent drainage area to get an equivalent bank full. Has anybody ever done that? I mean, is that for urbanization, that is, kind of like, we had really good hydrology down in Doleave. You could back out what equivalent bank full, your drainage area would be a lot bigger than what you're actually, what I'm saying? I mean, looking at what a natural stream channel would be, equivalent dimension.
Yeah, it's actually a very, it's a very difficult subject to discuss. So Luna Leopold, who's been in this field for a while, had done a study at Watts Branch up near Baltimore years ago. And at Watts Branch, he started doing geomorphic study with Reds Woolman. And what he looked at was where Bankful was at the time. This was back in the 60s. Well, since that, they had a lot of urbanization. And one of the last papers that Luna Leopold published before he passed away, I think it may have been in 2005, was the publication of it, was looking at the geomorphic adjustments of Watts Branch. And what he found out was that the Bankful channel, the channel enlarged, and we see this a lot of times where it will enlarge 3 to 5 times in urban environments. So the channel enlarged, but yet the Bankful channel did not enlarge. So it downcut, and it created this idea of multiple terraces, but yet the Bankful channel, where it got to vegetation, did not increase. One of the first things that I did back in 2002 when I started working for NC State was I helped develop an urban stream restoration, North Carolina urban regional curve. And we claimed that for an urban channel, you had to design it to be about 3 times larger approximately than a Bankful channel. When we did that, what ended up happening is our depth of water table was so low that it wouldn't support vegetation. And we had confinement of flows, and the natural flow regimes and sediment regimes couldn't withstand that channel unless we changed the substrate throughout the entire system and the vegetation potential throughout the entire system. So one of the things that Luna Leopold had said is that these valleys have been formed over years and years based on given flows, and we come here so shortly in such a short period of time that if we try to create a bigger channel that's going to change the distribution of forces, then a lot of times we don't have the materials available to do that with. So what we did with that Harris County regional curve that we showed was essentially trying to get to the point that you're talking about here. And I think that if we could start to develop where we could call what's called an urban terrace channel. So this is a channel that shows up in these urban environments. That's a channel enlargement, but it's not particularly a bankful channel because it doesn't allow for the same sediment exchange. It doesn't allow for the same revegetation potential as a bankful channel would. But we still need to kind of design that into something. I think that's where that hydrology modeling would be really important in the future. And I think that's the way that we'd want to start looking at it. And maybe some point it would lead ourselves to changing the size of these bankful channels. But what we've kind of seesawed back and forth is we want to, hey, bankful discharge will increase with urbanization, and we've created curves based on that. We've seen a lot of failures based on people building curves off of that. Then we went back with Reed and Watts branch stuff and Luna's stuff and said, okay, well, maybe the bankful channel doesn't change. And then we came back out and looked at things and said, well, no, there's actually something happening here. So maybe it's just another channel we have to look into. And that's kind of where we started moving to this idea of a 4-stage urbanized channel design. But I like the way that you're thinking, John. And we've definitely been thinking that way. We haven't come to a good conclusion, but I think there's a lot of work that could be done to try to look at the hydrology in urbanized environments. Like you said, kind of in Doleave, our hydrology was really simple. I mean, we just said what was the maximum discharge, and let's design to that maximum discharge. But when we start to look at something that's frequent enough for another terrace, it's probably something less than the maximum discharge.
Yeah, gotcha. Cool.
Dave, on the lower channels, when you're balancing clients' demands for view sheds and stuff like that, how do you balance the shear stress velocity on those lower channels? If your upper channel is staying roughly the same, your 25, 50, 100-year channel, but your lower channel, the clients wanting various view sheds, and sometimes they're wanting things in higher or view sheds that causes a higher shear stress on some bends or things like that. How do you balance that in your lower risk?
Yeah, so what we've done a lot is actually work with John Curry, who's on the line today. And we've worked with some other modelers too, but John's done a great job with us. And part of it is what we're showing here is a 2D model that John put together for us for a project. And it helps us figure out, okay, where do we need to mitigate the risk that we have? And a lot of times when we're looking at view sheds, it's really just, hey, we don't have native vegetation that'll grow here because they want to keep open a fairway or they want to be able to see through here. So how can we mitigate that? You know, is it a matter of putting down coir blanket? Is it a matter of putting down floodplain sills? So if you look on this picture, you'll see a series of lines that go across the floodplain. And this is a system where we're trying to preserve an upstream wetland on Tallahassee down in Alabama. And John had modeled this for us. And we basically were taking a braided system and we were trying to transition it into a single thread system so we could take it underneath a bridge. With that, our shear stresses came above what we felt comfortable with a threshold shear for on the floodplain with different discharges. We were looking at the highest discharges. So what we did is we went in and we buried a whole bunch of log sills and rock sills across the entire floodplain. Now, you can't see them, but the whole idea is that when we get up to those higher shear forces, that will be something that helps hold the channel in place. So it looks fairly natural, and you can see some rock structures. But if you look at the plan to the left on this slide, you'll see a lot more rocks that are designed in there that you don't see. So that's kind of some ways we look at it. I'll distribute to the entire group something called stressful mitigation a PowerPoint presentation that we use with urban drainage and flood control in Denver that helps talk about dealing with some mitigative measures when people don't want to allow natural vegetation to grow to its potential. John, do you want to talk any about the modeling of the hotspots? Do you have anything you want to add to John Hinkle on the line, John Curry?
Sure. Yeah. So the great thing about these 2D models are, it takes into account momentum. So, if you're using a 1D model like HEC-RAS, it's gonna give you your average velocity, your average shear stress. I did a lot of work back in the late 90s and early 2000s on scour and cohesive soils, where we use these for designing bridges and computing scour. What we found is I've got several examples of where we could actually predict the shape of the scour hole, and then that's what kind of led to using these because you can spatially see the difference of what I call a hot pocket of velocities or a hot pocket of shear stress, and where you see it start to get up or flare up, that's usually where you're going to see some issues. And what's really neat is some stuff, it's just not intuitive. I mean, that's what the best part of these models are, that as long as I've been doing it, I'll expect one thing, and then there may be a little bit of a contraction that you just don't pick up. I mean, you don't see it until you actually see it in the surface, and it makes it stand out, and you're like, oh, okay, yeah, I see that. So yeah, it's a really good tool. I mean, it seems like a really good fit for this type of work.
And Hinkle, Jonathan Hinkle, for me, I used to run some 2D models, some quasi three-dimensional models. Over the last number of years, I just find really good friends that can run these models and know how to put together something that they can put into a model, because it's always good to have another eyes from somebody that's more experienced or at the same level of experience as me running a model, because there's things that jump out that aren't intuitive that I want to discount, but it's nice to have that discussion with somebody else. So I would encourage you, maybe get up with somebody like John Curry if you want and talk to him about some things, or find somebody that is good at this modeling. It's not that you can't learn the model, it's just it's really good to have another set of eyes looking over these designs with us when it comes to modeling. So
it's always good to have friends, Dave.
Yes, it is.
The problem I see is, when I run a 2D mesh analysis or something, it's the client always wants that view shed right where the high shear is occurring, and it's amazing that always happens.
Yeah, we'll show. I mean, we have some things that are kind of similar to that, but a lot of it's just kind of saying, okay, well, if that's what they really want, this is how we can design around it. And joint planted riprap we've had places where we've had to deal with 7 to 8 pounds per square foot in transitional zones, and we just joint plant riprap, and then in a couple of years, it's kind of like Mickey Mouse land. It's it looks really pretty. It's not real, but it's just a matter of how do you transition to boundary conditions. So.
Right.
All right. Well,
Thanks,
I'll stay on the line for as long as anybody wants to, and I hope everybody has a great week this week. Thanks, guys.
Thanks, Dave.
Thanks, Dave. See you guys.
Thanks, Dave.
Hey, Dave. Good morning.
Hey, how you doing this morning?
I'm okay. How are you guys?
We're doing good. We had a cooked out on the fire last night and ate some really awful marshmallows. We pulled them out of the storage, and we thought that they would be good if you cooked them, but they were as hard as a rock. We could hardly put them on the stick to cook them. That's how hard they were. So the marshmallows were definitely the low point of the day for me, but the rest of it was pretty good. We tried to air out the camper, so we had all three of the bump outs in the camper out. We hadn't opened it up since we took it down to Texas, when you and Bissett took it down, you Raquel and Bissett, and you, Raquel and Mason took it down to Texas. I don't think we ever had the sides of it opened out. Well, maybe we did at the big house, but we hadn't had it that much. So we had mud wasps in it and everything else that we had to kind of clean out. So we had a good day. That was good. How are you doing?
Pretty good. Yeah.
Have you been out walking much, or
Yeah.
have you? Good.
Yeah. Yeah, looking for things to work on this week, I think.
All right. Do you have it? Did you have anything else? I had this morning. What I'd like you to do first in this morning is just look at the detail that was sent back over to us from Josh, and just kind of go in there into the detail, the PDF, and just add comments and questions related to what your thoughts on it, and then we'll try to go over that together maybe in a couple hours. So if you have any kind of comments or thoughts, and we'll go over that with Josh so we can get that out the door. Have you had a chance to look at it much yet?
No, I haven't.
All right, so that'll be kind of your first task this morning, to look at that. And then does Crystal have anything that she had you working on this week yet, or are you done working for things with Crystal right now?
I think I'm done working with her because I didn't work with her last week for now.
Okay. So are you going to be on the SWCA calls this morning? Does that kind of fill up your morning until sometime after 11 like it does for me?
Yes, it does. Yeah.
Yeah, that's kind of what I thought too. So how about first look over this detail in the morning and make comments, and then right after lunch, we'll kind of try to get Josh on the line. And then I also want to have a meeting with you and Ken, and we're going to look over a way of predicting sediment yields for Buffalo Creek watershed for Strontius Springs this afternoon. I want you to start looking at some representative reaches. I'm going to have Luis look at it as well, and then you and Ken. And my hope is that we can use LiDAR and aerial photography to predict sediment loading rates over the last 15 years since a fire on Buffalo Creek watershed on Strontius Springs. So that's what we'll do, and I'll have Ken on the line. And I'm guessing that phone call will probably be right after lunch, around 12:30 or something. But we essentially, what we're going to do is, I didn't want to go out and survey a whole bunch of tributaries when we have really good LiDAR data, and I think I can predict sediment loading from this LiDAR data, and I'm going to want to document it pretty well because if we do it this way, it will be fairly unique in the sense that I've never seen it done the way that we are, and something I'd like to share with people in the future. But the idea is that if we have really good LiDAR today, and we have really good aerial photography today, then we can make some assumptions based on changes in colors of vegetation, and then we should be able to predict how valleys have adjusted since a time frame of a fire when we have good aerial photography in that time frame. So it'll be a very a new concept to both you and Ken, and also Luis, so it'll be kind of fun to go over that this afternoon.
Sounds good.
So this morning, if you want to do anything before the meetings, then go over that detail with Josh, and then we can discuss a time during the meetings with Josh on when we can get together with him and go over any revisions that might be needed to that detail.
All right, sounds good.
All right, man. Well, we look forward to seeing you someday. How's Amani doing?
She's doing good. Hanging in there.
Hanging in there. Are they
Yeah.
She had mentioned when she talked to us on Zoom couple weeks ago about food shortages and stuff. Are they seeing much in the way of food shortages? Are they doing okay, or?
They're doing okay for now, I think.
Good.
Yeah.
And then are they
Yeah.
have any? Do they have any end to their lockdown?
Yeah. Candy area has opened up, which is part of their.
Okay, good.
You've been to Candy and the Maligaw, right? The house.
Yep, you betcha.
Yeah. So that area has been opening up, but the capital hasn't yet in Colombo. So.
Okay. Yeah, I
So
imagine that was
there's-
probably more of a hot spot than anything else, just because of all the commerce.
Yeah.
So,
Yeah, there's more activity over there than Candy, so they still have it locked down.
yeah, we Abby and I were wondering about. We were just driving somewhere, and we're like, I wonder if you can get a flight to Sri Lanka yet. So we Googled and saw that you can actually get a flight to Sri Lanka right now. It's super expensive, but you can get a flight, which surprised me. So.
Yeah, I'm not sure if they fly though, but I'm not sure if the airport's open. So
Yeah, well, yeah, I guess yeah. We just went to see if we could buy one for like last week. We're just like, I wonder what happens if you wanted to fly there next week. And it said that you could fly there. They wanted $5,000 a ticket. So it makes me think that it might be open, or maybe it's just an airline that's selling you a ticket and then they're going to tell you that you can't fly there later. I don't know. But yeah, we were surprised by that because we had thought that it was closed as well. So.
yeah.
And have you heard any new news on when she'll be able to come over, or just still kind of holding on that?
Just still holding on it. We're still waiting for an interview email confirmation.
Do you have to go back to Sri Lanka
No,
for
not
an
me.
interview for that? So she's the only one that has to go there. Gotcha.
Yeah, just her. Yeah.
Are you hoping to go back over again at all before she comes over here, or are you hoping the next step is that she comes over?
Hoping the next step would be she'd be coming here. So we'll see.
Good. Yeah, I
Yeah.
hope so too. So
Yeah.
cool. All right. Well, very good. We will talk to you. We'll talk. I'll talk to you during the SWCA calls, and then we'll figure out what time we'll talk to Josh right after those calls, and then what time we talk to Ken related to Strontius Springs, since I don't know what his
That's a
quality
good
is.
day. Sounds good. See you in a bit.
Have a great day.